Hello and welcome to this week's episode of Automated. I, of course, am Stefan Seltz-Axmacher, CEO and co-founder of Polymath Robotics and one of your hosts here at Automated. Opposite me is someone who is wearing a Polymath Robotics shirt. He is wearing a smartwatch that is not Apple, so I don't understand what it could possibly be. It's not Apple or Pebble. Who exactly are you, sir?
I'm starting to feel that these intros are getting more and more into the "so what are you wearing today" kind of description, which I think is an entirely different podcast. Not our client base, I gotta say. Maybe we steer back away from it.
Too much Dr. Drew growing up. Love line. So this is our weekly podcast, Automated, where we do two things. First, we play a game where we spitball a robot together, and then we talk about a topic in robotics. Now, this just happens to be our 20th episode. It's the big 2-0, where you're old enough to be drafted and no longer be a teenager, but young enough to still not be able to drink in America because we're the greatest country in the world.
Or, flee north over the border for weekends.
So before we talk about what we talk about, I want to talk about something that I got today, because that's more important. Some time ago, one of the guys on our team, Zurich, who's like really fantastic controls engineer, who's doing lots of cool things, asked kind of sheepishly, like, "Hey guys, would it be cool if we had Nerf guns in the office?" And that led to a number of questionable purchases on my side.
Thus, the arms race began.
And like the arms race was first like cool looking Nerf guns that were actually rather cheap and manual, to a bunch of automated or automatic Nerf guns. Ilia, your Nerf gun appears to shoot bullets.
I of course did my research and found the fastest, most accurate model out there. Did the cost efficiency minimization. So Zurich in this case is our Oppenheimer, where he just set off the race. He has become Nerf death.
We've done calculations on the maximum number of newtons that can be put out by Nerf pellet bullets, darts, and then basically even the fastest you could fire them based on terminal velocity would still cause no damage to a person, which might be the point. Along the way, the idea of a robot Nerf gun came up time and time again. And Ilia, whenever I brought this subject up, how did you respond?
Oh, I had said I had a small project back at a previous employer where we had a Nerf turret that we had controlled over USB. They're out of production, unfortunately, but you used to be able to get these little USB controlled. Nerf.
Those were on ThinkGeek.
Yeah, exactly.
They were like fake.
Exactly.
They're like fake Nerf, except they had all the same dimensions.
Exactly. And what we did, we ended up coding up a little script that knew where everybody sat just by counting ticks on rotation of the thing. And anytime anybody would break the build, it would automatically figure out the blame and shoot that person with a Nerf dart to tell them that they have to fix the build.
So with that idea, I was like, we should have a Nerf gun that can freely move through the office to strike fear. It turns out that Nerf did used to make this. It's a product called the Nerf Terra Scout that was released in, I think, around 2016. It was in Popular Mechanics back there. It's a diff drive robot that's teleoperated. Which is to say, it's a small remote control tank with a Nerf turret on top that streams digital video to a remote control that can be, so far in early testing, 10 to 15 feet away.
Amazingly digital video. I was betting $5 that this was just old style analog RF video. Nope. Has latency of 1.5 seconds.
Yep.
Just terrible digital video. Such a weird design choice.
It makes your attacks on the interns and younger employees a lot more difficult when you have a second latency to deal with.
I think our youngest full-time engineer printed out a psychological safety poster after getting shot.
After I may or may not have shared a screenshot from the controller of his face in the crosshairs of this little tank. So, given you've had a lot of big promises about this, I think our game today should be, how exactly do we make this autonomous?
So it drives around the office, finds you, and shoots you if you broke the build.
Maybe we could say whether it's directed at a person. It could just be kind of like a T-Rex. It shoots anything that moves.
Oh, that's less fun. Let's make it directed at a person.
Okay. Yeah. So facial recognition.
No, nothing that complex. It's just we don't move desks that often. So if this desk is occupied,
but
probably it's that person.
You could achieve the shooting people's desks by mounting a bunch of those USB turrets on the wall, which we will do. That is coming. But more, what I mean is a hunter killer type of robot to track individuals on our team.
So we build Skynet.
Yep.
It monitors the office.
Yep.
And if the wall-mounted turrets can't get you, it goes out and searches for the person.
Yeah. Yeah. I mean, and like we have roughly, I don't know, we don't have that big of a space to drive in maybe 600, 800 square feet. So it just has to, hunt around there for specific people and then shoot them.
So, and we start, our base platform is this Nerf. What did you call it?
Terra Scout.
Wow, that is a terrible name.
It's a great name. It scouts the Earth.
For terror.
Yeah.
Okay.
No, Terra.
Oh, Terra.
Yeah.
Okay, that's a slightly better
like
name.
the X-Terra.
Okay.
It means X-Earth.
I thought they were making a real faux pas there on the name.
Yeah. Probably not in post 9/11 America.
Yeah,
Are they calling a robot the Terror Scout? They have a product like that, but they only sell it to Northrop Grumman.
Yeah, they're Nerf weapons and R&D division. But what's funny is you looked into this and you had found somebody had already reverse engineered some of it.
A pen test guy reverse engineered a bunch of it and figured out how to do something with it, but a butterfly flew by my desk and I got distracted.
Yeah, I think he ended up having to look at hex code and all that kind of stuff. I think my suggestion would be the first easiest step would probably be to tear out whatever little integrated circuit they have there for control and put in something different and just use the platform mechanics for the treads and the motor and all that, right?
Yep.
That's the cheat code.
Yep. Now the problem is our office does have stairs.
Yes.
Right. So we probably need edge detection or cliff detection.
Yep.
We probably need, like, if we're going to recognize people by their face, we probably need better compute to run that machine learning.
I mean, maybe, or the trick I had used before, I played with an early version of Amazon's photo recognition. Mm-hmm. There's some trade name for it. Anyway, and you can take a snapshot and just do an HTTP request with that little snapshot and it will return from a database that you've pre-programmed. So if I took everybody's photo in the office and then that little robot just take a snapshot, throw it to Amazon and get back an answer. So you don't need as much compute on board.
We could basically, there could be like a Slack command that is, shoot Ilia.
Yeah.
And it then drives up to everyone, scans their face, Ilia, not Ilia, until they find you, and then it shoots you. Then it lets all 10 fiery darts let fly at you.
This is an even less tasteful version of hot dog, not hot dog. But I think,
how much compute's needed for that old Amazon thing?
Basically nothing. Okay. Like you can do the HTTP request on Arduino. You just have to be able to throw an image file. So you need a camera on this thing.
Oh, there is a camera already.
Yeah, but again, hacking into a camera, much harder than just buying a cheap camera module. You can get little ESP32 camera modules for like $8 these days.
Yeah.
Not worth your time to reverse engineer the existing camera on there. Like drastically not worth your time. And this thing will do combined image taking.
So we rip out the old camera.
Wi-Fi, exactly.
And run this one in its place.
Yeah, this little ESP. But then that little microcontroller can't do all of your navigation.
Yep.
And obstacle detection and cliff detection and that kind of stuff. So maybe we skip that step. We go straight to a full computer, like a Raspberry Pi equivalent that could have a little full MIPI CSI camera.
Yep. Right now, it only has like a 9-volt lithium ion battery or LiPo battery or something.
Yeah.
Would I be burning through my power faster? Because I only got a good, 60 shots off at the team earlier today before the battery died.
Yeah.
So I'm not sure if I have a budget for a lot more power draw.
Oh, that's a good point, because you want this thing to actually be able to wake up.
Yeah.
Right. So you need some sort of
hunter killer.
Yeah. You need a wireless power transmission.
Yes.
So funny note for folks who've never fought with this problem. A robot plugging itself in, surprisingly difficult.
Incredibly hard.
So, hilariously difficult. In particular, you can make kind of charging contacts that the vehicle bumps into passively, like Roomba does this quite often. But the complexity of actually getting that right is fairly difficult because you have to do the perfect amount of pressure so that the metal contacts actually contact with a low conductivity.
I have a friend.
High conductivity.
I have a friend who was building electric vehicle charging stations with robotic electric charging arms, and like they got it to work on like 3 models of EV.
Yeah,
as long as there were certain colors and not other colors. And now they help you figure out where to place an EV charging station.
So here we go. This is actually what we do to make this cheap and dirty thing. We get an old Android smartphone.
Okay.
It has all the compute, it has the cameras, has the Wi-Fi, and it has wireless charging usually built in.
Well, I mean, not like a super old one, like not my like Galaxy S10.
No,
like,
something in the last 2 years.
Yeah, right. Yeah. Old,
but not ancient. And what you then do is that this is both your brains and your sensing package, most of it. And you can run
and your charger
and your battery system, right?
Yeah.
So
are you going to keep it also in the phone package, or
and have a little connector to the USB port.
Connect a selfie stick to the Terror Scout, and boom.
There you go. No, because you can usually do USB host mode on most of these most of these phones, so that the device will be like a computer, and then you have a little plug-in USB board, which is a USB device, which can be the actual tank.
Yeah.
For your control of your treads and your thing. And that's actually might be reasonably elegant to the point where it's just a phone and a connector.
And since Android's Linux based, I mean, wouldn't be the biggest leap to have a virtual machine running ROS.
Yeah, or virtual machine, or just little node that talks to another computer, or whatever you want, right? That's probably a clean kind of way to do it from the junk drawer, that you don't have to buy a custom board.
And it also means that you don't have to spend $25,000 on sensing and compute and all this stuff.
Yep.
Like Samsung's already done that for you.
Yeah, exactly. The IMU is usually pretty decent already.
Yep.
So all of that, the camera is usually fairly like higher quality than any $8 module you could possibly buy.
Definitely higher than they get retailed for $75.
Yeah.
Definitely higher quality than the Terror Scout.
Yeah, I think probably just the camera module on high-end phones tends to be that cost. Yeah, so that makes sense. But then we still need some way to position indoors. So maybe we have LiDAR.
I mean, we are a robotics team. We should decorate the walls with April tags anyway.
Yes.
We could just basically have like a baseboard around all corners of the office that's just a series of April tags. And everyone could be required to put April tags on their desks and on their backpacks, and frankly on their faces.
So yeah, I was gonna say easier change, right? Required ClearPath dress code. Polymath t-shirt with a unique April tag on the chest.
Yep.
Which is unique per person.
Yep.
So the robot just has to look for the April tag. And because April tags, usually the higher end families can support like 300, 400 different tags.
Yep.
So this can scale to a bigger company pretty easily.
Yeah, I mean, so if you want a hunter killer droid at your office, you can get a Terror Scout and a smartphone.
And there you go. And a little bit of soldering with a USB device, and you're good, ready to rock.
I mean, it seems to me like you just solved how to build this as an actual product, or not product, as an actual hackathon project.
At the yeah, for sure. Well, okay, hang on. We've forgotten though. We have positioning now. We can detect people. We can recognize them either through face or through April tag or whatever. We still can't avoid obstacles.
Well, don't any of the smartphones from the last 2 years have LiDARs on them, like iPhone does?
iPhone does.
It's a crap one, but
yeah, I don't think any of the Android ones really do. And even if they did, they're usually very short distance.
What about your favorite of all sensors, ultrasonics?
Yeah, you could throw ultrasonics in there. Problem is, you're probably going to end up with a higher cost than just putting together something small.
Yeah.
For a small side project of mine, I'd put together a low-cost ROS development platform, and it used ST Micro LiDAR sensors, basically. You can get these little $10, $12 modules that have a few meter range.
Yep.
And you could sprinkle, 5, 10 of those things around the perimeter, and you'd get a pretty decent view of the world. Really low resolution 3D LiDAR.
But it doesn't really matter. It's mostly important that you can go find people on the team and you can empty 10 darts into their face.
I mean, really, really fun part though is we have one of the classic killers of robots, which is really clean, transparent glass doors in the middle of our space with no edges around them.
Well, we do have an informal only Nerf guns inside that office role.
No, but imagine we didn't.
Yeah.
Right? So how the heck do we detect really transparent, frameless doors, which humans can sometimes smack into because you're just not going to notice them? Well, there's nothing telling you that they're there. That's a fun one. That's actually a place where ultrasound does make sense, where you can detect a hard, transparent object, transparent to LiDAR light, camera or image light.
So we have trouble. Well, we're planning on getting a new office sometime soon anyway. So we'll just have a requirement for that office and not have glass doors.
Or put a piece of tape around the bottom
with April tags on it.
Yeah. Same tape. Same localizing tape.
So that being said, it looks like the total cost of this project, we're thinking an old smartphone, maybe like $40 to $80 of LiDARs, and I don't know, 40 to 100 hours of robotics engineering time.
Yeah, plus a little circuit board to go from USB host device to the things, which I haven't torn this thing apart, so I don't know. But you'd have to a little bit of motor drivers and stuff, like nothing big.
Yeah.
But you could probably slap together a bunch of Adafruit parts and get to somewhere around $100 BOM on that.
All right. So we're looking at, $200 plus an old phone.
Yeah.
Why hasn't it been done yet?
Time. those 100 hours, man. That is a solid hackathon weekend.
So with that being said, let's break into our regular segment, which today, I think just kind of generally as an overview. So why are robots so hard? Why is it like, I even found myself, like, when I first opened that toy and started playing with it and shot a bunch of you a couple of times, walking over to this room to do a meeting and thinking, like, oh, but like, wouldn't it be cool if we just like threw some quick autonomy on there? And like, I was almost amazed at myself for letting myself think that. Why is it all still so hard? And like, what are we doing? What are we seeing at Polymath to make it easier?
Yeah, no, absolutely. I think one of the main things is there's no defined kind of plug in a bunch of sensors and you get autonomy out.
Mm-hmm.
ROS gives you a toolbox for that. And if you follow a very narrow set.
A toolbox where for that Nerf Terror Scout, if you know exactly what you're building, 100 hours later, you might have a cool toy.
Exactly. So it's better than coding it from scratch, but kind of out of the box functioning robot is very... It's very hardware
elusive.
Specific. Well, it's very, if I want to use the term, but artisanal almost.
Yeah.
It's, what happened with the Industrial Revolution is a standardization of parts.
Yep.
Where different components can be interchanged. So manufacturer A and manufacturer B could make the same bearing, and the same bearing would work in different machines. And that seems obvious today, but that was a complete novelty during the Industrial Revolution, where you didn't have to go back to your original manufacturer to fix your equipment. I think the robotics is still in the artisanal mode right now.
Yeah.
Where nobody but Polymath knows how to fix Polymath robots.
Yep.
And nobody but ClearPath knows how to fix ClearPath robots. And nobody's really built a common set. Now, again, ROS is that toolbox.
Well, but to be fair, it hasn't been necessary because there's so few that are doing well.
Yeah.
I was catching up with a friend the other day about how, a particular large, heavily invested in industry in robotics is essentially a bunch of dead companies walking. And like there hasn't been the need for standardization because there hasn't been the volume to support beyond initial R&D projects.
Which is interesting because you'd think, something like the audio industry, if anything, would have the volume to support this kind of use case, but even they haven't built out enough.
The line that I've heard from someone who does automation of automotive factories is people look at these factories and think they're, just a bunch of robots doing stuff. And the best factories in the world are 7 to 8% robots. And Tesla has really upped the bar by automating 12% of their actions, 14% of their actions. And that's a game changer for them.
Yeah. But not even forget the factories. The cars themselves. Going back to an earlier episode when we were at CES, there's 2 or 3 dozen LiDAR manufacturers.
Mm-hmm.
Every one of them with a weird custom driver, weird custom electrical interface. Yep. You had to,
if you looked at the Embark auction, the self-driving truck company Embark just failed. They're in the process of auctioning off all their hardware. There's like 40 different types of LiDAR that they tried out and that they're auctioning old units of.
Good luck getting a 10-year-old LiDAR to work. Like, even assume it's mechanically perfect.
Yeah.
Good luck finding the software and having that software run in a modern OS and have anybody support it. Like it's the equivalent of
something that people often forget is LiDAR itself is kind of a robot. It's like it's a robot that doesn't quite sense, but it moves around while spraying out lasers and collecting data.
It's shocking to me that I think largely because of consumer pressure that USB webcams are almost sort of plug and play. 99% of the time, if you plug in a USB camera, it just works.
Yep.
Which is shocking, right? Because it's a vision sensor.
And to anyone to think about what video calls were like 15 years ago, it wasn't just the streaming that was the problem. It was the sensor.
Yeah. The hardware was garbage and custom weird driver for your
and update
AOL.
That driver every time you log in.
Yeah. for your AOL account with an extra special add-on for video. Like you had to buy a little USB mouse. Have you ever heard of QCats?
No.
So my mom got into this where she bought one off of auction for like $3.
Uh-oh.
Where this was one of these startup failed companies that decided that what the world needed was barcodes on everything. And that every person would love to have this little barcode reader that was shaped like a cat. It was a QCat.
Naturally.
And when you barcode read something, right. And when you barcode read something, it would take you to some early proto website where you could get discounts on this thing. And I think like they made 50,000 of these things.
Yep.
And I think 12 were bought. One of them being my mother, like way later, because she got it on eBay or something like that. Where, custom weird hardware that nobody knows how to use.
On Facebook Marketplace all the time, because it's San Francisco, I see people trying to sell the Anki Cosmo robots.
Yeah.
If you know those. So Anki was a robot toy maker who the team joined Waymo, and they had these cool robot toys that someone's trying to sell some of on Facebook for $200. Like, this thing's almost certainly bricked.
Yeah, there's no way to use it.
Yeah.
And again, I think to come back to your question, the interesting thing is the Anki robots, and to make a buck selling to consumer toys, you have to heavily integrate everything to the point where you have this custom processor with a custom sensor with a custom chassis, and nobody but Anki knows how to run this thing.
and in reality, any robotics team also, they themselves barely know how to run it.
Yeah. And so robotics is stuck in that mode. And we're kind of, our viewpoint is we're trying to transition robotics more towards the server infrastructure world, where it's just, I don't care where my Gmail runs. It runs in the cloud somewhere. I don't know how it runs. I just log in and it just works. I don't
really need to care about this hardware, about this sensor, about this compute, about this vehicle underline.
Google figures out how to hand deliver the bits from my web client to that server. I don't have to worry about it. And I think robots have a long way to go there. And I think even us, despite our best efforts to productize it and to make it portable and to make it work on different architectures, we're still going to have a long fight ahead of us.
Yeah, but we are seeing some really cool progress.
Oh, for sure.
I mean, like, we're starting to see customers who the other week we had a customer ask us about a vehicle that's a rather novel kinematic model, which when we first built out that kinematic model, we thought, who else would ever ask for this? And then here we are reusing it. We just had a customer say, oh, hey, would it be okay for you to do this particular use case where two robots interact with each other? And we have already built that for another customer.
Yeah.
So we're starting to see a lot of these, like, at our layer, they feel like apps, but really they're still enabling technologies.
Exactly. But to put a little bit of the tech detail into it, we're working towards a future where we really don't care what hardware or you're using, what compute, what sensor.
Yep.
And we're fighting that fight really, really hard. But even a concrete example where we say, okay, but if you, the client, want to run some special deep learning infrastructure, you're probably going to need an NVIDIA GPU.
Yep.
Sorry, that's the way the world is today.
Yep.
You can fight for 3 months to avoid that, or you can just install the libraries and go about your life. And so there's a kind of a very similar fight where we're trying to make sure that our distribution images can work across different hardware and make sure that we don't have to lock people in. But there's a balance where clients come to us and say, but I just want a robot. I don't know what machine you need. Just tell me what to buy.
And I think, honestly, that's already happening. There's already people who are choosing the OEM of their equipment based on who can support autonomy the most easily. So as the last kind of like brainstorm question before we fully wrap it up. So if today is 1980 in robotics, it's just a line that we throw around a lot. Let's talk about what 1995, 2000, 1998-ish looks like for me shooting people in our office with Nerf darts. Like, what are the things that like exist? Like, I for example think the actual navigation, if Polymath does its job, is something that you can clunkily, painfully buy, much like you bought Windows 95, and would just work on that vehicle. Now, there might be drivers that are required. There might be that you have to kind of install, and you can mess up installing them and really like think you're very technical.
And we can ship a Polymath Clippy that says like,
oh, we need Clippy.
It looks like you're trying to install localization.
But like, what's this problem of I want to shoot Nerf darts at our interns look like in the proverbial 15 to 20 years?
I think we can make a lot of magic progress to the point where if you have maybe not a cell phone, but if you have some computer, some Raspberry Pi equivalent or some Intel equivalent, to have kind of a one-click, like, download this image, it'll flash it with our custom OS, our custom software, bam, you're off to the races. That includes our drivers for the top 200 sensors. So if you pick any one of these and plug it in, we'll auto-recognize it, we'll auto-configure it. Self-calibrates, self tells you what its capabilities are. I think the one remaining piece is you're still going to need to do the electrical engineering work to convert how the Nerf people are controlling those motors to the computer. There's still that little piece that you just can't get away from. And so we've kind of called that
standardization. Everything could be USB-C.
I would love that, but I think it's not going to happen.
15 years. We're not talking next year. We're not talking 4.
But even 15 years away, like it's hard to make that economic argument, because the question is, if I'm a manufacturer of toys, for example, why would I use a standardized interface when it's an order of magnitude cheaper just to have a custom ASIC for it?
Maybe it won't be an order of magnitude cheaper if USB-Cs get that far. However, so but if that problem gets solved by the market, you download our OS, and then it's just a matter of writing some code that you might be pulling from something like an OpenAI to help you write.
Especially ChatGPT.
Right? I want code to be able to hunt around my office and find someone with this face.
You know what would be amazing, actually? Sorry, one last note is if ChatGPT stretches into the electrical engineering design domain, where you just say, like, ChatGPT, I've torn apart this thing, and there's these 4 wires, and when I connect these two, it does this. When I connect these two, it does this. Build me a circuit board, please. And it just does it. That would be fantastic.
You are probably the first person to say that out loud.
So, what are we talking about next week?
Well, I have an idea of what we're going to talk about next week, but it's going to depend a lot if we can get a press release together by then. We worked on a cool little hacky project recently that we're excited to share. It's exactly the type of hacky project that some people will be very excited about and think is amazing, and other people will be like, "Yeah, obviously that's 5 hours." So I'm excited for that. I think that might be next week.
So
if OpenAI can write our press release for us.
So on that tantalizing note, we'll see you next time.
Yep. See you next time. Thanks so much for joining us.